Hello friends, today we are going to start linear differential equation and its application, and every solution in linear differential equation and its application start with complementary solution. So we first solve the complementary solution. So rules for complementary solutions are, there are four rules. Rule number 1, when roots are real and different, then yc is c1 e raised to m1x, c2 e raised to m2x and plus cn e raised to mnx. When roots are repeated, when 2 times repeated, then yc is c1x plus c2 e raised to m1x. When 3 times repeated, c1x square plus c2x plus c3 into e raised to m1x is yc. When roots are 4 times repeated, that is m1 4 times, then yc is c1x cube plus c2x square plus c3x plus c4 e raised to m1x. When roots are imaginary, that contains I, then roots having format d is equal to alpha plus or minus I beta, and its yc is e raised to alpha x because alpha is the real part and beta is imaginary part. So c1 cos beta x plus c2 sin beta x. When roots are imaginary and repeated, then roots like alpha plus or minus I beta, alpha plus or minus I beta 2 times repeated, then yc is e raised to alpha x, c1 cos beta x plus c2 sin beta x. Now we solve some examples on these four rules. Example number 1. Solve the differential equation d2y by dx square plus 5dy by dx plus 6y is equal to 0. First, we have to write its auxiliary equation. How to write auxiliary equation? We have to write compulsory right side as 0. Remove y from left side. So d2y by dx square will become d square. 5dy by dx will become 5d plus 6 is equal to 0. Now finding the roots. This is quadratic equation. This equation has two roots. So roots are minus 2 and minus 3. Now minus 2 and minus 3, they are different, real and different. So we have to apply rule number 1 of complementary solution. So yc will become c1 e raised to minus 2x plus c2 e raised to minus 3x. Now example number 2, solve d raised to 4 minus 4d cube plus 6d square minus 4d plus 1 into y is equal to 0. So its auxiliary equation is simply we have to remove y. So this is auxiliary equation. Now this is fourth order differential equation and having formula d minus 1 raised to 4 is equal to 0. So d minus 1 4 times and its roots are 1 repeated 4 times. So for 4 times repeated, having formula yc is equal to c1x cube plus c2x square plus c3x plus c4 e raised to m1x. So this example has solution yc is equal to c1x cube plus c2x square plus c3x plus c4 e raised to x. Now example number 3, d2y by dx square plus 2dy by dx plus 2y is equal to 0. Its auxiliary equation is d square plus 2d plus 2 is equal to 0. Roots are imaginary and 1 plus or minus 2i. So yc is equal to e raised to 1x because 1 is real part, 2 is imaginary part. So c1 cos 2x plus c2 sin 2x. And last example, d cube plus 4d into y is equal to 0. So its auxiliary equation is d cube plus 4d is equal to 0. By finding the roots, d is equal to 2i minus 2i and 0. 2i and minus 2i, they are imaginary. So plus or minus 2i I have written here, and 0 is real and different. So I have written separately 0. yc is c1 e raised to 0x plus for complex c2 cos 2x plus c3 sin 2x, and e raised to 0 is 1. So yc is c1 plus c2 cos 2x plus c3 sin 2x. So these are the four examples. You can solve at least 10 to 15 examples for yc. Thank you.